Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial number 5, Soil Model Applications for Various Geotechnical Problems. So if you remember in previous two tutorials, we talked about Mohr-Coulomb constitutive models and also hardening soil model. However, there are many soil constitutive models available in PLAXIS 2D. So in this tutorial, we will shortly talk about these constitutive models and the suitability of this model for different types of geotechnical problems. So when we open the PLAXIS, if I open the PLAXIS, in here we have show materials. If I click, and in here if we select the soil and interface and click on new, in soil model, if I expand it, as you can see, we have various soil constitutive models, from basic linear elastic Mohr-Coulomb to advanced soil constitutive models. So actually each of these constitutive models is most suitable for a specific geotechnical problems. So in this tutorial we will talk about this. So we talked about Mohr-Coulomb and hardening soil model, and also there are other soil constitutive models like hardening soil model with a small strain, which is derived from the main hardening soil model. Also for soils like peat or soft soil, we can use these materials, soft soil or soft soil with a creep effective. Also we have other constitutive models like modified camp clay, NGI-ADP, other models like Hoek-Brown for simulation of rock behavior in PLAXIS 2D. Also we have a jointed rock model for simulation of rock model in PLAXIS 2D. Also we have a concrete model for simulation of structural concrete in the PLAXIS. So actually you can see the details for each of these model in PLAXIS material model material manual. So as you can see, this is the material manual of PLAXIS, and you can see the details for each constitutive models in detail in this manual. So I recommend to read about each soil constitutive models before using in your project or for the research purpose. So in this table, as you can see, in here we have a material model, and in here we have a geotechnical problem like a foundation, excavation, tunnel, embankment, slope, dam, offshore structure, or any other geotechnical problem. So for each model, for each geotechnical problem, there is one letter, for example C, A, or B. So according to the PLAXIS material model, the A is the best standard model in PLAXIS for this application. For example, if we take a tunnel as an example, we can see in here the hardening soil with a small model is a best model to be used for tunnel simulation in PLAXIS. But it doesn't mean that the other model is not good or bad. For example, the choice B, it means a reasonable modeling. It means we can still use this model for this application. For example, when we take a foundation, for example, in here we have a hardening soil model, which is B, but hardening soil small model is A. It means the best model for foundation we can use as A. For example, if we see the slope if we take the embankment, we can see the Mohr-Coulomb model is C for this geotechnical problem. C, it means it is a first order approximation. So as a first check, we can use a Mohr-Coulomb model for the embankment. But if you can see, for example, in here we don't have the linear elastic. It means we cannot use a linear elastic model for tunnel or slope, dam, etc. So besides A, B and C choice, in here we have 𝐸𝐷𝐶𝐬𝐬. Maybe it is available in here. 𝐸𝐷𝐶𝐬𝐬 is model. It says this model is for cyclic analysis in case only undrained strength is known. So UBC 3DPL model also available in PLAXIS, and this model is mostly suitable when we have a liquefaction plus dynamic analysis. Also, the letter with asterisk is an alternative model for PM for sand, which is available as a user-defined soil model in PLAXIS. So if you see this model PM for sand in here in PLAXIS, we cannot see PM for sand in here. But if I select a user defined and after that click on mechanical, in here we can see this model, which is PM for sand. So for example, for excavation, as we can see, the linear elastic also is a first order approximation, so we can still use it, and Mohr-Coulomb also we can still use it, and the hardening soil model is reasonable modeling. But if we want to choose the best standard model in PLAXIS, we should use the hardening soil with a small strain model. So we have other materials also, like soft creep model, soft soil model, jointed rock, or concrete model. So and we can see in here also, for example, if we see an excavation, this model also is good. For example, soft soil creep model, it is still a good choice, which is B, or jointed rock model, it's also B. And modified camp clays, a first check we can use for these types of geotechnical problem. So I take this table also from PLAXIS material model, and I recommend also you study and take a look at this table. So in here also you can see applicability of the material model for different types of soil, for example, concrete, rock, gravel, silt, over consolidated clay, normally consolidated clay, peat or organic soil. So as you can see, the Mohr-Coulomb, we can it's a reasonable choice for rock or concrete, and hardening for gravel and for other types of soil as well. And hardening soil model also is a good choice for this soil material. And you can see the other materials for different types of the soil. So this was for this lecture. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.